Today we're going to cover arc length and sector area. To start out, we need to start with the basics. For arc length, we need to remember how to find the circumference of a circle. To find the circumference of a circle, see, it would be pi times the radius times 2, or pi times the diameter. Okay, where r is the radius and d is your diameter. So if I were looking at this circle here and they told me the radius was 5 centimeters, to find my circumference, I would simply do 2 pi times 5 centimeters. And I leave it in terms of pi, which would give me 10 pi centimeters. You can change it to a decimal if it requires you to. If that is the case, then you give me 3 places after the decimal. But what I'm saying right now is leave it in terms of pi. Makes it go a lot faster. Now here's a different circumstance. They tell you the circumference is 19 pi centimeters. They want you to find the radius. So we know that's equal to 2 pi times the radius. So we divide by the 2 pi. The pi's would cancel. I get 19 over 2 centimeters, or 9.5 centimeters. Okay. Now let's see how this plays into the arc length. The arc length of a circle is part of the circumference of the circle, just a part of it. So, if I was looking at circle A here, and it had a circumference of 84 pi centimeters, what is the length of the arc? To know this, you need to know the arc length formula, which, if I were to switch over to here, you can see it right here on your formula guide. It's arc length over 2 pi r, which is your circumference, equals the measure of the arc divided by 30 degrees. So if I come back here and I set that up, my arc length is x, I don't know it. 2 pi r, isn't that the circumference? Well, they gave it to me, 84 pi, and that's equal to the arc measure of, now see, this is a typo, it should not say ABC, it should say BCD. Okay? So I know 360 is on the bottom over here, but if I look at BCD, I need to figure out its arc measure. Well, I look, EAD is 90 degrees, which means this other side is also 90 degrees, because BAD, the segment, is a diameter, which means arc BCD is 180 degrees because it's a semicircle. So my arc measure, because it's a central angle, is 180 degrees. Now 180 over 360 can reduce to 1/2, to where all I have to do is cross multiply, and I would get 84 pi, and then divide by the 2 to give me my arc length, which would then give me 42 pi, and that would be still centimeters. Okay? So that's how you get arc length. Well, let's try the length of ED. Again, still 84 pi for your circumference, still 360 on the bottom over here. Don't know what the arc length is, that's what we're finding. Arc ED is 90 degrees. Now 90 over 360 can reduce to 1 over 4. So that in turn makes x equal to 84 pi divided by 4, which gives me 21 pi centimeters. So arc length doesn't seem that bad. Let's try another one. What is the length of arc AB? Again, simple setup. Remember, 360 always goes here. 2 pi times the radius, since they gave me radius of 10 inches. Okay. I don't know the arc length, but I do know that the arc measure is 72 degrees. In this instance, we are going to have to cross multiply. So 2 times 10 is 20 pi inches. And then 20 times 72 gives me 1440 pi over 360. So I divide the 1440 by the 360. And I come out that the arc length here is 4 pi inches. Not so bad, right? Alright, one more. The length of arc AB is 12 pi. Now they've given me the length of the arc, and they want the radius. So I need to do 2 pi r, right? The length of the arc is 12 pi. Automatically, my pi's are canceling, right? Okay? And 146 is my degree measure. So again, it's cross multiply and divide. So to cross multiply, I do 12 times 360, and I get 4320. Then 2 times 146 is 292 times r. So divide by 292, right? Simple algebra here, guys. This should not be hard. And I get my radius is 14.795 meters. Let me make sure I'm redoing my math. Okay, and there we go. Now, we're going to switch gears and we're going to start talking sector area. To find sector area, you first need to find the area of a circle. The area of a circle is equal to pi times your radius squared. So if I had this circle here with a radius of 3 feet, the area would be pi times 3 squared, which is 9 pi feet. Don't forget your units. Okay? Area is not so bad. What if they tell you that the area is 36 pi? What is the radius? That's easy. Your pi's would cancel off. So 36 is equal to r squared. So take the square root, and you get that your radius is 6 centimeters. Okay? Alright, now we've done area of a circle. Now we can talk about sector area formula. Okay? If you go back and look at your formula guide, over right next to arc length, there's the sector area formula. It says the area of the sector divided by pi r squared, which is the area of the whole circle, equals the measure of the arc divided by 360 degrees. So sector area is how much area a piece of the circle takes up. So if they want the sector area of angle ABC that's created by angle ABC, I simply know that's my x. I know 360 is on the other side of my proportion. I know my measure is 80 degrees. Then pi times, what's my radius? 20 squared. Okay? And 80 over 36, 360 goes down to 2 over 9. That makes this a whole lot easier. I do 20 squared times 2. It gives me 800 pi centimeters. And I divide by 9. That would be centimeters squared, actually. Divide by 9. I would just leave it at 800 pi over 9 centimeters squared because, remember, we want to keep it in terms of pi. And if I cannot reduce this at all, so it'd be 800 over 9 pi centimeters squared. Let's do another one. All right, the sector area. They give you the area on this one, guys. The sector area is 40 pi. This is pi times my radius of 9 millimeters squared. And they want the arc measure of angle ABC. Again, my pi's cancel. So I'm going to do 40 times 360, which is 14,400. Divide by 9. Oh, not divide by 9. Divide by 9 squared. There we go. And I get that that angle measure is 177.778 degrees. There you go. Let's see what else we got. There's another one. The area of the sector is 40 pi. And that would be pi times 9 squared. Then 360 and x, right? Well, didn't we just figure out x was 177.778 degrees? That's going to come in handy because they don't ask for the arc, the degree of the arc. They want the length of the arc, which means I have to go back to my formula guide and I have to use the arc length formula now. Okay? So I put in the 177.778 degrees on the top, and I put 2 pi times 9 for the circumference, and I put a big X on the top. So now I have to do 2 times 9, which is 18, times 177.778 degrees, and divide that by 360. And I get 8.889 pi millimeters. Alright, that's it. Come see me for tutoring if you need to. Oh wait, hold on. Okay, so I said that was it, but I was wrong. There's one more problem. Now look at this one. You have a triangle inscribed inside of a circle. Circle D has an area of 81 centimeters squared. That immediately tells me you're doing sector area first. They talk area, it's sector area. So you know it's pi times the radius squared. They give you the sector area of 81 pi centimeters squared. And if they tell you BC is 14, they want the length of arc AB. You first need to figure out if you really do need the sector area formula or not. So the first thing you have to do is you have to think, what do I need in order to do arc length? Well, I need the circumference of the circle. You need the circumference of the circle, so you need your radius length. And you need the arc measure. So, if I look at this, I do know that angle B is inscribed from arc AC, which is a diameter. And an inscribed angle is half of the arc that it creates. So if this arc is a semicircle, it's 180, so half of that, this would be a 90-degree angle. Okay? And what I need is the radius. And I need angle C because it's inscribed by arc AB. It creates arc AB, which is the arc length we need, the arc measure and arc length. So we have to use a little bit of knowledge to figure these things out. So what we have to use is, okay, what we have to use is we have to use this area to find our radius, because we know that area is pi times the radius squared. So I have to divide both sides by pi and take the square root. So I know that my radius is 9. So if my radius is 9, that means AC is 18. Segment AC is 18. Okay? So now I need to use trig to figure out angle C. So I'm looking, I have hypotenuse and I have adjacent. So I'm going to be using inverse tan. No, inverse cosine. Why did I say tan? Adjacent and hypotenuse is inverse cosine. So I'm going to be using inverse cosine of 14 over 18 to get that angle measure of theta. And that gives me an angle measure of 38.942 degrees. Now that's angle C. I need arc measure of AB. That's not so hard. I just multiply it by 2. And the arc measure ends up being 77.885 degrees. So now I can do my arc length formula. 77.885 degrees. 2 pi times my radius of 9, x on the top, cross multiply and divide. So multiply that by 18, divide by 360, I get 3.894 pi centimeters, and that is my final answer. Okay, now that is the end of the notes. If you have any questions, please feel free to come and ask me during tutoring. Thank you.